Okay, so we continue with this discussion. Now, we have the standard form of quadratic function is this, and we look at the a, okay, the coefficient in front of x squared for some properties, especially how the parabola opens. Okay, we know that when a is positive, parabola opens upward, and we have the vertex is the minimum point. When a is negative, so our parabola opens downward. Okay, and another term for this opens downward is a concave down. Concave down. And now the vertex is what? So the vertex is the highest point. Is the highest point, and we call it a maximum point. A maximum point. Okay. So how does the graph look like now? Okay, x, y here. Okay. And this here, alright, vertex, but that's also a maximum point. Okay, so the graph. Now in the exam you will have to identify the maximum and minimum point of the function of the function. Okay. So the next question, next important topic of discussion is actually graphing. So you have to graph these functions. And how do you graph a typical function? The most basic one is y equal to ax squared. Okay. So let's suppose that I want to graph the function y equal to 1/3 x squared. Right? How would I start? Now, let's do some observation first. The first thing is this is a quadratic function. Okay, so it's a U shape or parabola. Okay, we have to know this. Second one is a, since it's a parabola, so a is 1/3, so this is positive. So my graph, my parabola opens what? Positive, so opens upward. Okay, or another term for this is concave up. Okay, and the next thing is you need to find the vertex. Okay, so what would be the vertex for this? Now in this section it doesn't give you the formula for the vertex. As we learned in 9-2, the formula for the vertex is x equal to -b divided by 2a. Okay, -b divided by 2a. And here's the reason why you need to understand and point out the a, b, and c in the standard form. Okay, we'll come back to this later. But then also the next one is a symmetry. Okay. Symmetry. What is the symmetric line? Okay. What's the symmetric line? And then we want to know the domain of this function. Also the range. of this function as well. Okay, so let's look at the domain here. We know that let's sketch. Okay, all right. I think that to be more exact, we need to make a table of values. So x here, y equal to 1/3 x squared, right? So the first value that I would get is actually 0, because it would be easy. So 0x here, y would be equal to 0, right? How about number 3? Okay, I know that 3 because it would be divided easily. So 3 here, y equal to 1/3 multiplied by 3 squared would be equal to 1/3 times 9 and 3. Okay, and then 6, 1/3, 6 squared, right, equal to 12. Okay, so I have these values. Now let's find the vertex, because the vertex here, the formula here will give you the line of vertex as well. Okay, the line of symmetry, right? Remember that in previous discussion we know that the vertex is also on the axis of symmetry. So here, when I find that x equal to -b divided by 2a, I also know the axis of symmetry. How will I find out the vertex? I know that y equal to, our function is y equal to 1/3 x squared, right? So from here, if I write in the standard form, it would need an x and a c, right? So because we don't see anything after x squared, we assume that it's 0. So it would be 0x plus 0. So from here we have a equal to 1/3, b equal to 0, and c equal to 0. Right? So vertex here would be equal to -b, which is b equal to only 0, divided by 2a would equal to, 2 divided by 3. Right? And we know that 0 divided by any number is equal to 0, so we already have this is equal to 0. Right? So when x equal to 0, I find y also equal to 0. So this is the values that we have. So 0, 0 is, here in this case, 0, 0 is the function vertex, right? It also the minimum point is the minimum point. And another conclusion is OY is the axis of symmetry. Axis of symmetry. So what it means is that OY here is the axis of symmetry. Okay. So I only have to graph the 2 points on the right, and then because of symmetry, I can actually match them to the left. So what it means is that I say here's 1, so let's say 3, okay, 6 here. I have, let's say, 3, 6, 9, 12. Okay, so 3, 3, 3 at this point, and 6, 12. this point. Okay. So because of the axis symmetry again, so we know that because of symmetry, -3 here, -6 here, and symmetry can match from this, okay, without having to find the other values because these are the symmetry. Okay, so here, so I can actually graph them by matching these. Okay, so this is the, sorry, it has to be, okay, so this is y equal to 1/3 x squared. 1/3 x squared. And the domain. Now, let's look at the domain here. So the graph actually, as x approached to negative number, the graph continued to grow up. Okay, and as x approached to positive number, y also approach, so y also increases. So what it means is that we don't have a restriction for the x, values of x. Okay, so the domain is that with x belong to the with all the real numbers, right? With all real numbers. How about the range? We see that because look at the vertex, okay, the minimum and maximum. So the minimum of this, the minimum value of this function is 0, 0. So the range is actually y is greater than or equal to 0, right? Because y values here cannot be below 0. So it's actually restricted. Y only take values, have the values from 0 upward, okay, to positive infinity. Now, let's do some discussion about the finding domain. Okay, some typical popular functions that require domains. One is a ratio, so a divided by b. So if this is a function, the domain, so let's say let's suppose I have the function f of x equal to ax divided bx. Okay, so what it means is actually the numerator is a function of x and the denominator is also the function of x. We would have the function in the denominator has to be different from 0. Another case is if I have a rational function. So for example, f of x equal to the square root of 8 of x. Okay, so under the square here is a function of x in terms of x. So the domain of this, the requirement is that the function a of x has to be greater or equal to 0.